I apologize in advance. I recorded this video and for some reason it didn't pick up the audio. So what we are going to work on in this video is questions 1 and 2 of the activity. So the first thing that you have to kind of read through all the criteria that is given to you. So we have a dead load of 50 pounds per square foot, a live load of 100 pounds per square foot, Fy is given to you, E is given to you. We know the floor will support a plaster ceiling. We will do the interior beam together, question 1, and then exterior beam, question 2, you will do with either by yourself or with a partner. When I'm talking about interior and exterior beams, you need to look at that framing plan and realize which ones are interior and which ones are exterior, because that will change tributary width. So we are going to start on question 1, and the first step is to write out all the given information that is provided. So dead load is 50 pounds per square foot. Live load is 100 pounds per square foot. Fy is 50,000 psi. Tributary width we are going to have to find in a second, so I'm going to leave that blank. And the span we are also going to have to find. And then what am I looking for? So I'm going to do a little find column, and I am looking for a W12. Okay, so my tributary width, I have to look up at my framing plan, and I looked at the interior beam. It needs to support the load halfway to one side and then halfway to another side. Okay, so I'll draw that out here. So here are my 3 beams. They are 6 feet 8 inches apart. And so my interior beam is responsible for, again, halfway on either side. So my total tributary width is 6 feet 8 inches. So we'll write that down in the given. Next thing we have to figure out is the span. So how long is the beam? So if you read your framing plan, you can see that that is 18 feet. Now we're ready to move on to step 2, which is find the total loading. So we have to do the uniform load. So there's a few steps for this. First step is going to be to find the uniform load of our dead load. So uniform dead load I'm going to abbreviate as WDL. Because again, uniform is represented by a W when we look at our equation sheet. So WDL, that's my uniform load on my for my dead load. So the equation is dead load times by tributary width. So I'm going to plug in my numbers. I know my dead load is 50 pounds per square foot. And my tributary width is 6 feet 8 inches. Something that's very important to know is I need to convert that 8 inches to feet. So once you convert that to feet, it is 6.67 feet. Multiply that out, and you get a total uniform dead load of 33.5 pounds per foot, or pounds per linear foot, PLF. Okay, so next step is to find our uniform live load. So I'm going to erase everything here and start back up at the top. So again, this is question 2 we are working on. Second step of finding our total uniform load is to find the uniform live load. So WLL equals the live load times your tributary width. And then all we have to do is plug in our numbers. We know our live load is 100 pounds per foot, or excuse me, pounds per foot squared. Multiplied by our tributary width, which is 6.67 feet. And we get a total of 67 pounds per foot, or PLF. Please put a big rectangle around that, marking out your answer. Alright, so now we know our uniform load for the live load and dead load. So now to get our total uniform load, we just need to add them both up. So plug in your numbers. We got a uniform dead load of 33.5 pounds per foot, plus our uniform live load of 667 pounds per foot. for a total of 1,000.5 pounds per foot. And we are going to round up, because we always want to round up to make our load heavier than it is. So we're designing a beam that is stronger than it needs to be. So always round up, make a note of that, and put a big rectangle around your answer. And that concludes steps 1 and 2.